Alright, this is the last chapter of the semester, chapter 10. So we're going to start off with 10.1, which is going to be a review of kind of Pythagorean Theorem and simplifying square roots, which you've seen before. So a radical is an expression like these over here that has a square root or a cubed root, stuff like that. We're going to be dealing with square roots because we need that for the Pythagorean theorem. And so, like the square root of 52, if you wanted to do it with a calculator, you would go second and then that x squared button down next to the 7, and then the number itself that you want to put inside. So in this case, the first one's 52, and I get 7.2. That's if I want to use a calculator, and we can round to the nearest tenth for that. So the calculator, we'll put calc for calculator, gave us 7.2. Now, if we didn't have a calculator and we had to guess or estimate, then we would have to go through and think about perfect squares. And 7 squared is 49, and 8 squared is 64. So you'd go, well, since 7 squared gives us 49 and 8 squared gives us 64, 52 is somewhere between these two numbers. So it's got to be somewhere between 7 and 8. So if I didn't have a calculator, I would estimate somewhere between 7 and 8. Looks a little closer to 7 than 8, so I'd go maybe 7.4, 7.5. So this would be my estimate if I didn't have a calculator. So like over here, let's pretend I don't have a calculator. I'd go, okay, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81. 81 is the first one that's bigger. So I go, okay, 9 times 9 gave me 81, and if I go back to 8, 8 times 8 was 64, then 74 is somewhere between these two, so between 8 and 9, I'd say, well, let's call it 8.5. And then on the calculator, if I want to check my answer and see how good my estimate is, I use that same button like before, so I go second x squared, and then the 74, and I got 8.6, which is pretty close. So for estimating without a calculator, being able to find what's in between will get you a pretty good estimation. Over here, the square root of 20, if I'm doing my estimate, I go 4 times 4, that's 16, 5 times 5 is 25, so 20 is between these two numbers. That means that the square root of 20 has to be between the 4 and the 5. So I'd go, okay, well then that's about 4.5. And then on the calculator, checking it once again, I would go square root of 20 is, and I got 4.47, which rounds to actually 4.5. Last one of these, square root of 150. 12 times 12 is already 144, and 13 times 13 is 169. So I go, okay, 12 and 13, and 150 is between these two numbers, so it's between 12 and 13. I'm going to call it 12.5. And then on my calculator, square root of 150, and I got 12.2. So 12.2, pretty close. For this next section, we're using the Pythagorean theorem, and it looks like it's going to be so much more difficult, but really it's not. Because remember, Pythagorean theorem was a squared plus b squared equals c squared. These squares are going to cancel out those square roots. So Pythagorean theorem, the two that are touching the right angle, those are supposed to be the ones we call the legs. That's a and b. C is always going to be the hypotenuse. So like on this example, you'd go the square root of 5 squared and the square root of 6 squared equals c squared. This square root and that square will cancel, so the first term is just 5. Square root and square just cancel, so the next term is 6. And then c squared doesn't cancel because there's no square root on that. You combine these two together, 5 and 6 makes 11. And then from here, if I want to get what's c by itself, I'm going to square root both sides, so that that'll get rid of that square, and I have c on one side. I'm going to put it on the left. And on the other side, if I want to know the exact answer, I have to leave it like this. But if I want to know the decimal answer, I'm going to use my calculator, square root 11, and I get 3.3. So if I'm rounding to the nearest tenth, I'm going to use 3.3. If I'm going to use the measurement for anything in the real world, I would probably get the decimal. Next example, same deal. We're still using Pythagorean Theorem. Hypotenuse is still going to be the C value. The two touching the right angle are still going to be your legs. So you're going to go a squared plus square root of 3 squared equals square root of 7 squared. Once again, the square and the square roots will cancel each other out. A squared stays a squared. Square root of 3 squared is just 3. Square root of 7 squared is just 7. And then to move this across the equal sign, I'm going to subtract 3. A squared equals 4. And then if I square root this one, I already know it's 2, but square root of 4, I get 2. For simplifying, you do not give me a decimal answer. So I'm going to put right here, no decimal, putting it in capitals. I'm going to put an exclamation point on there. If it says simplify, you cannot give me a decimal answer. You're supposed to factor it out, and you guys have done a factor tree before. You did it when you were younger, where you factor it out, and then you go, okay, 12 can be 2 times 6. 2 doesn't factor anymore. 6 can be 2 times 3. 2 doesn't factor anymore. 3 doesn't factor anymore. You look for pairs. So like right here, there's a pair of 2s. That is going to go on the outside. And then the one that doesn't have a pair, the 3, is going to stay on the inside. That is a simplified radical. Do not give me a decimal. 28, we're going to do the same thing. So I'm going to factor out 28. I can go 2 times 14. And then from 14, I can go 2 times 7. And now these are all factored out. Look for my pair. So 2 on the outside, 7 on the inside. There's my answer. 54. I know I can divide by 9, so I'm going to go 9 times 6. And then 9 can be 3 times 3. And then 6 can be 3 times 2. And then I'm looking for pairs. So even though there's 3 3s, I'm only going to use a pair of them to go outside. And since I only have 1 3 and I only have 1 2, and it's not a pair, those go inside, but I multiply them together. So 3 times 2 is 6. There's my simplified answer. 112, I know that it's an even number, so I can divide by 2. And if I do that, I get 56. 56 is still even. I can divide by 2, and that gives me 28. 28 can still divide it by 2. That gives me 14. 14 can divide it by 2, and that gives me 7. And after all of that dividing by 2, I see a pair here. I see another pair there, and then I have this 7 that doesn't have a pair. So this 2 is going to come outside. This 2 is also going to go outside of the radical, and that 7 stays on the inside. 2 times 2 on the outside can get multiplied together, and your final simplified answer is 4 square root of 7. For this last part on the front page, it says multiply the radicals and simplify your answers. There's that simplify again. That means no decimals. If you factor it out and look for pairs, actively look for your pairs, then if there aren't any pairs, you don't have to worry about simplifying. So watch. Square root of 5 doesn't factor. 6 is 3 times 2 or 2 times 3. There's, even with all of these factored out, the 5, the 3, and the 2 don't have any pairs. So that means that all of these just get multiplied together, and they're going to stay inside of the radical sign. So 5 times 3 is 15. 15 times 2, we're up to 30. That would be your simplified radical form for your answer. Over here, same thing. If I get this, 3 doesn't factor out. 12 is 2 times 6, and 6 is 2 times 3. So I factored out the 12. And then I see there's a pair of 2's here. And be careful, because there's also a pair of 3's here. And then those are going to go on the outside of that square root. So the 3 and the 2 would go on the outside, and there's nothing in the square root. 3 times 2 is 6. We don't need the radical sign because there's nothing inside of it. Your final answer would be 6. For the 8 and the 2, 2 doesn't factor out. 8 is 2 times 4, and 4 is 2 times 2. This 2 is just coming down. So I have a pair of 2's here, another pair of 2's here. I have 2 2's that go on the outside of the square root sign. there's no need for that square root sign, so my final answer would be 4. Number 14. The 5 was already outside. Be careful with that. This square root of 3 and this square root of 3, neither one of these can come outside, so I don't need to factor it. I can just go, there's a pair, it goes outside with the 3, and then I don't need the radical anymore, so my final answer is 5 times 3, 15.